Hi math students, it's Miss Carol again, and we are now working on Unit 3, Lesson 11 project. We again have 7 questions. So I am going to jump right in. We are still on the same scenario where we're rebuilding or redesigning a community center. So first question, Yesenia and Xavier are creating a model of the new community center to share with the park director. Working together, the model will take them 12 hours to complete. If they each worked on it individually, Yesenia would take 10 hours longer than it would take Xavier. Their hourly production rate can be given as 1 over y plus 1 over x equals 1/12 of the time. So if they take 12 hours together, then 1 hour is 1/12 of the time. That's where that comes from. So y is Yesenia, x is Xavier. Which of the following equations correctly substitutes the expression for y in terms of x? So remember that Yesenia is going to take 10 hours longer. So y equals, let me get my pen going here, y equals x plus 10, right? Yesenia takes Xavier plus 10 hours. So we can just simply substitute x plus 10 in for y in this equation, and we will end up, get rid of that. We will end up with 1 over x plus 10 plus 1 over x equals 1/12, okay? Remember that this value here is the same as y. So essentially this is the same as our first equation. Okay, question number 2. Refer to our previous answer, and now we need to rearrange the equation into standard form. Start by multiplying both sides of the equation by x plus 10 to eliminate the denominator for the first term on the left, and then which equation correctly shows that result. Okay, so essentially, what I'm going to do here, I'd like to write this out because it can be just a little bit confusing. Remember, we had 1 over x plus 10 plus 1 over x, okay, equals 1 over 12. And all they've asked us to do here is to multiply everything by x plus 10. Okay. And if you multiply one term by x plus 10, you have to multiply every term by x plus 10 so that your equation remains balanced. All right. So x plus 10 over x plus 10 plus x plus 10 over x plus x plus 10 over 12. Remember, when you're multiplying fractions, it's kind of the same as having these over 1. So when you're multiplying fractions, you just multiply straight across. And 1 times x plus 10 is simply x plus 10. 12 times 1 is 12. And then this should be an equal sign, not a plus. Okay, so the only thing that I still need to simplify is this. X plus 10 over x plus 10, regardless of what x is, let's say x was 1, then we'd have 11 over 11. Except if x was negative 1, we'd have 9 over 9. So regardless of what x is, this will always simplify to 1. So now I have 1 plus x plus 10 over x equals x plus 10 over 12. Okay, so it looks like that is this one. Okay. Question 3. To eliminate the denominator for the second term on the left side, multiply both sides of the equation by x. So now, if I remember right, we're continuing on with that same answer. We've got 1 plus x plus 10 over x equals x plus 10 over 12. Okay, so now they say, okay, now multiply everything by x. So I'm going to do that in a different color here. That might help. If I multiply this by x, and I multiply this by x, and I multiply this by x, okay? Well, 1 times x is just x, okay? In this one, though, the x's are going to cancel out, and essentially what that's doing is taking the x out of the denominator, which becomes very helpful, and I'm just left with x plus 10. So x plus 10 equals, and now I've got x plus 10 times x over 12. And I could distribute that through, but it looks like in the answers that they've provided here, they didn't. They left it very simply as x times x plus 10, all still over 12. Okay, so we're just going to leave it in that same format. Okay. And I'm just going to scroll down so that we're left with this because we still have another step of multiplying everything through by 12. Okay, these are very sequential, intentional steps. Basically, this is kind of the same as finding a common denominator for all of these, but what we're really doing is getting rid of all of those denominators. So now let's multiply everything through by 12, and I'm going to go back to pink just so we have a difference. Okay, so when I do it on the right, I get rid of the 12s. When I do it on the left, I get 12x plus 12x plus 120, 12 times 10. And then again, it looks like we're leaving everything in the x times x plus 10 format. All right, so that is right here. We have yet to simplify this. Okay, now it says from this equation you can distribute, use inverse operations, and combine like terms to put it into standard form. So now this is where we're going to simplify everything and put it into standard form. I'm just doing this because it's a little bit more of a white screen and we can work with that. So let's combine like terms on the left. Okay, this becomes 24x, and I still have 120. I'm going to distribute. Okay, x times x is x squared, and x times 10 is 10x. Okay, because I really like to keep my a term here positive, I'm going to bring these terms, my terms on the left, over to the right. So I'm going to subtract 24x and 12 from both sides. When I do that, I get 0 on the left, and I'm going to subtract 24x here and 12. So I'm going to be left with x squared. Actually, 0 equals x squared minus 14x and minus 12. Okay, let's see which form they want us to enter this answer in. They do want us to say that it equals 0, and they want everything on the right side of the 0. So we're going to enter it in just like this. We're going to say x squared minus 14x minus 12 equals 0. Oh, sorry, not 12. It should be 120. let me correct that really quickly. We should have, it's this 120. So 120, 120, and 120, and 120. Too many 12s and 120. They all kind of look alike. So this is 120, and we're setting it equal to 0. Okay, so x squared minus 14x minus 120 equals 0. And now, since we have that great equation, now we can factor it. Okay, so this is going back to what we did in the last lesson. And we need to find all of the factors of 120. And the factors that multiply together to become 120 have to add together to get negative 14. So let's just start with our factors of 120. I know I've got 1 and 120. I have 2 and 60, 3 and 40, 4 and 30, 5 and 24. Let's see, probably 6 and 20, 7, 8, 9, 10, and 12, and that's as far as I can go. Okay, so any of these, if one of these is negative, because one of them does have to be negative so that I can get a negative 120, if I have any one of these factors negative, can the other one add to it to give me a negative 14? I can see that it won't work anywhere but here. If the 20 is negative, then when I multiply them together, I get a negative 120. But when I add them together, I get a negative 14. And that's exactly what I'm looking for. So my factors here are x plus 6 times x minus 20. And I still have to set it equal to 0. Okay? All right, last question. Explain how you got your answer for the previous problem by describing the pattern you identified and the technique used for factoring. Be sure to be clear and concise, blah, blah, blah. So what I would do here is I would say that I found all of the factors of 120, and then I figured out which of those factors, if one of them was negative, that I added together could give me a negative 14. So I'm going to let you put that in your own words. You can see exactly what I did. If you need to rewind it and describe it in greater detail, you can definitely do that. But go ahead and just describe how we got to x plus 6 times x minus 20 being equal to that x squared minus 14x minus 120 equals 0. Okay, so thank you so much for joining me for lesson 12, and I'll see you back here for lesson 13.